Welcome to your lesson 7.4. Today we're going to evaluate logarithms and graph logarithmic functions. We will need to do this lesson over two videos. So we'll do the first 4 examples and then we'll stop when we get to inverse functions and we'll move on to video 2 at that point. Okay, so your objective today is to learn how to evaluate logarithms and to graph logarithmic functions. So what is a logarithm? Let b and y be positive numbers with b not equal to 1. The logarithm of y with base b is denoted in base b, logarithm of y there. You've got the little b there is a subscript. Everything else is on the same level. And it is defined as follows. The base b logarithm of y, or the log base b of y, whichever way you want to say it, is equal to x if and only if b to the x equals y. So there's this relationship here that there's the logarithmic expression and then the exponential expression of the same relationship. Okay, and to move between the two, it's really easy. The way that I've come to talk about it is that you swoosh it. Okay, so if I want to go from logarithmic expression to exponential expression, what I do is I start with the first number value, typically the base, and I go to the outer and then back to the middle. So it makes a little swoosh thing. So it's b to the x equals y. See? B to the x equals y. And if I'm in exponential form and I want to go to logarithmic form, I write down log, and then I start with my base. It's going to be base b of y equals x. Log base b of y equals x. So the expression log base b of y is read log base b of y, or you can say the base b logarithm of y. Either way is fine. Okay, so we're going to rewrite some expressions, some equations that are in logarithmic form, and we're going to write them in exponential form. So here we've got log base 2 of 8 equals 3, or the base 2 logarithm of 8 equals 3. And we want to put it in exponential form. So we come to the base and we start our swoosh from there. So it's going to be 2 to the third equals 8. So 2 to the third equals 8. Okay. We have the base 4 logarithm of 1 equals 0, or log base 4 of 1 equals 0. And we want to write it in exponential form. So 4 to the 0 equals 1. Okay, and then we have an example here where we've got the base 12 logarithm of 12, or log base 12 of 12 equals 1, and we want to put it in exponential form. So 12 to the first equals 12. And there you go. It's 12 to the first equals 12. And finally, we've got the log base 1/4 of 4 equals -1. Or the base 1/4 logarithm of 4 equals -1. So we want to put it in exponential form. So it's 1/4 to the -1 equals 4. Okay, there are some special logarithm values that you need to know. You need to memorize these little facts. The base b logarithm of 1, or the log base b of 1, is always going to equal 0 for any legitimate value of b. And that's because b to the 0 always equals 1. Anything to the 0 power equals 1. So anytime you're taking any kind of logarithm of 1, it's going to simplify to be 0. Anytime you have the base b logarithm of b, that's going to simplify to be 1, because b to the first equals b. So anytime these two values match, you're going to simplify to 1. Okay, so we're going to evaluate some logarithms. We've got the base 4 logarithm of 64, or if you want to say the log base 4 of 64. What I want you to do to be able to evaluate these is set the original expression equal to x. And that's going to give you a little logarithmic equation. And then you're going to write the equation in exponential form. You're going to swoosh it. And then you want to rewrite the equation with the same base on both sides, and that'll make more sense once we look at an example. Once you have the same base on both sides, we're able to set the exponents equal to each other and solve. And whatever x equals, that's what your original logarithm evaluates to. So I have the log base 4 of 64 equals x. So I'm going to rewrite this in exponential form. So I'm going to have 4 to the x equals 64. All right, once I have 4 to the x equals 64, my goal is to get the same base on both sides of the equation. Well, I know 64 is equal to 4 to the third power. So I'm going to rewrite it as 4 to the third power, and this gives me the same base on both sides. Well, if the whole equation is true and we've got the same base, then the exponents must be equal to each other also. So x must equal 3, which means that the log base 4 of 64 is equal to 3. Okay, I've got the log base 5 of 0.2, so I'm going to go through the same process. I'm going to set it equal to x. And then I'm going to rewrite my equation in exponential form, so I'm going to swoosh it. So I'm going to have 5 to the x equals 0.2. Well, 0.2 is equal to 1/5, which is the same thing as 5 to the negative 1 power. And so I'm going to rewrite 0.2 as 5 to the negative 1. Now I have an equation where I've got the same base on both sides, so I have to be able to set my exponents equal to each other, so x must equal negative 1. So the log base 5 of 0.2 is equal to negative 1. Okay, we've got a couple more of these. We've got the log base 1/5 of 125. We're going to set that equal to x. Okay, and then we're going to swoosh it. We're going to put it in exponential form. We've got 1/5 to the x equals 125. So let's see. I know 125 is 5 to the third power. And I know 1 over 5 is the same thing as 5 to the negative 1. So I can get a base of 5 on both sides. So let's simplify a little. I've got 5 to the negative 1 to the x power. Negative 1 times x is negative x. So I have 5 to the negative x equals 5 cubed. Okay, since I've got the same base, I can now set my exponents equal to each other. Negative x equals 3, so x equals negative 3. So the log base 1/5 of 125 is equal to negative 3. We've got the log base 36 of 6. So we're going to set that equal to x. And then we're going to swoosh it and write the equation in exponential form. 36 to the x equals 6. Let's see. 6 is just 6 to the first, and 36 is 6 squared. So let's go with the base of 6. So we've got 6 squared to the x equals 6 to the first. So I've got a power to the power over here on the left. So that's 6 to the 2x equals 6 to the first. So now that I have the same base on either side, I need to set my exponents equal to each other. So I get 2x equals 1, divide both sides by 2, and I get x equals 1/2. All right, a common logarithm is a logarithm with a base of 10, and that base is so common, we just leave it off. So if you see something that just says log 5 or log 27, that means common log of 5 or common log of 27, and the base is understood to be 10. Now, we introduced e as the natural base. If it is the base of a logarithm, it is the natural logarithm, and it is indicated by the symbol ln. That means natural log. In general, a logarithmic function is going to have the form g of x equals the log base b of x, and b is going to be greater than 0, it can't be negative, and it's not going to equal 1. So let's make sure you can use your calculator. The second function of the 10 to the x key is the logarithm key for you. Now, your calculator does allow you to enter whatever base you want to enter. So there is going to be a little box down here that allows you to put in whatever base you want. So if you put in a base of 10 here, it wouldn't be a problem. You just don't need to. To the right, there is a place for 8 is called the anti-logarithm. That's what you call the value that you're taking a log of. It has a place there for you to put your anti-logarithm in. So a place for 8. So don't put 8 down here in the subscript. You can leave it blank and the calculator will know you mean 10. Or you can put 10 in if that makes you happy. And then here in the box that's on the same level as log, that's going to be where you put 8 and you press enter and it gives you 0.9030899987. It doesn't necessarily round to the same place for your calculator. It depends on what your settings are. Okay, to check, you're going to do 10 to the power of this value, and it should come out to be approximately 8. Okay, now you want to do natural log of 0.3. This is a logarithm with the base of e. And it's going to be, what you want is the second function of your e to the x key. So you're going to do control e to the x, and you'll see ln pop up, and then you'll just put in 0.3. You'll press enter. And you get negative 1.20397280.4. And this means e to that value should equal 0.3. So to check, you just put that into your calculator and press the enter. All right, we're going to evaluate a logarithmic model just so you can see logarithms in action. The wind speed S in miles per hour near the center of a tornado can be modeled by S equals 93, common log of D, plus 65, where D is the distance in miles that the tornado travels. In 1925, a tornado traveled 220 miles through 3 states. Estimate the wind speed near the tornado center. Okay, so you write down your model, your function, and then substitute what we know. We know that we can substitute 220 for D, so let's plug that in. Now you could just type that into your calculator as is, or you can actually evaluate common log of 220. And so common log of 220 rounds to be 2.342 times 93 plus 65 gives us 282.806. So the wind speed near the tornado center was about 283 miles per hour because we just rounded 282.806 to the nearest whole number. Okay, well, that's it for video 1. Come back for video 2 and we'll talk about inverse functions and graphing logarithmic functions.